CP0 and CP1, right? And there are 4-bit outputs. So since you have already used, so can you just explain to your friends that why there are 2 clock CP or this clock pulse input? I'm expecting 1 clock input, right?
Yes, sir. Sir, this CP0 is for synchronization of this, and then the CP1, which is connected to A0, is for changing the bit in Q0, and successively all of these change. If we don't connect this, then the whatever the display will be, it will be frozen. It will not move ahead.
But probably I do not know whether you are aware of that reason.
No, sir.
As I said that, okay, I am expecting just a single clock input, but here there are 2 clock inputs. So actually, if you think about, okay, I think you may unshare the screen now. Thank you. So just a moment. So I think the other users might have faced some problem after this screen sharing. So am I audible now?
Yes.
The other, yes, no, I'm talking about the other that so-called the Jitsi Meet viewers. Okay, fine, thank you. So here in 7493 or 7490, I do not know, you must be knowing about these flip-flops and all. Maybe in your class 12 also, class 10 plus 2, those who are having computer science, then probably you are aware of what is a flip-flop, or maybe later on. So you are aware what is a flip-flop?
Yes.
So just can you tell us in one sentence that what is a flip-flop?
Flip-flop is basically a level triggered circuit.
No, in this case it is
flip-flop is an edge-triggered device where the output changes depending on the input. Like there are different types of flip-flop, and the output changes based on the input when you have a trigger edge, either the rising edge or the falling edge.
Right. So here actually we are having flip-flops which are getting triggered on falling edge. So how many such flip-flops will be required? Because the 4 outputs are there, so it is natural that okay, we require 4 flip-flops over there. So you require, just I'm drawing 3 flip-flops, and as I was used to draw that clock, so this side is that clock. So when I draw this bubble, that means it is actually triggered on the falling edge. So here we will be applying this clock signal, and the output of this, so this is basically a toggle flip-flop. So if you use something called a JK flip-flop or SR flip-flop, then you need to tie them together to logic high, then it will act as a toggle flip-flop. So I'm just referring to it as a toggle flip-flop right now. So the clock of the second flip-flop is derived from the output of the first flip-flop. It's called the Q. Q is the output. So Q of the second one goes to the input of the third flip-flop, and so on. So this forms a chain. So this is the output of this flip-flop, this is the output of this flip-flop, this is the output of this flip-flop. So if I call it something like A, B, and C, so then when do you think A will change? After resetting, maybe A, B, C all are low. Okay, so when do you think first A will change to 1?
With the first falling edge.
Can you tell a little loudly?
So with the first falling edge of the train.
Right, with the first falling edge of the clock. So first falling edge of the clock is this one. So here A will change from 1 to, so if I'm talking about A, till that point A is 0. Now A is becoming 1. So when once again A will change? Next falling edge, right?
Yes.
So A keeps on toggling whenever it encounters a falling edge. So it will be like this. What about B? B is the output of this flip-flop. So it receives the clock from the output of the previous flip-flop, which is nothing but the A. So now A waveform is here. So when do you think B will change? After resetting, B is also
The time period will be twice.
So A is serving as the clock for the second one. So let us see that when the falling edge at A is we are having falling edge of A here. So till that time B will not change. Now B will change here. So if I draw another cycle, so then A would have changed here, making another falling edge of A. So here, since A is getting applied to this flip-flop, so in the next falling edge here it will change. So now that creates a falling edge in B, which in turn you are feeding to the next flip-flop. So C will change only at that time. Okay. So if you think of this A, B, C now, then what are the values associated with them? So initially A is 0, B is 0, C is also 0. What I am writing, is it visible?
Yes.
Okay, so then A becomes 1, B and C remains 0, 0. Here in the next step, A is once again becoming 0, but B is becoming 1, C is remaining 0. In the next cycle, A is becoming 1, B is remaining 1, C is becoming 0. So what is the pattern? If I just rotate it by 90 degrees, then I think I find that, okay, it is nothing but that same counting sequence, whatever earlier we are writing with that ABC. It is 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, and so on. Okay. Now finally it is becoming here 1, 0, 0. Okay, so it is counting like this. So is there any question till this point, or you are aware already, possibly, when whatever I am saying?
Yes, sir, no question.
Okay, but I think that didn't answer why that should have two clock signal. I am talking about only one external clock signal, right? At this point, this is my clock. So now, if I ask you what I would have got or should have got inside a 4-bit counter, whatever I have drawn, what should be the difference with that drawing and a real 4-bit counter? So what would be your answer?
So I think with the last the MSB output so far, if you take it as a clock and once that goes for falling edge, then only the leftmost will toggle. So that will be.
Actually, you are answering the question which I have not asked yet. I was about to ask my second question. So you have answered to that question which your friends are not yet aware of, perhaps. So my first question was that if I am expecting a counter to have 4-bit output, so then what else it may contain, whatever I have drawn other than that?
A fourth flip-flop.
A fourth flip-flop. Okay, so that's natural. I expect you to react much faster. I think if it is in a physical class, I think it would have been much faster. So I am having a fourth flip-flop. So let me draw this flip-flop over here. I require a fourth flip-flop. It should have a clock input. It should have an output. So where should I connect it? Suppose I have drawn right now in isolation. So where do you think, I think if I have to connect with this chain.
C goes to clock of fourth one.
D goes to?
C goes to clock of fourth one.
C goes to, okay. So you are saying that as if, I mean, it would have been nice if I have drawn this one over here, just like this, that in a chain, okay. 7493 actually has got exactly what I have drawn, that is 3 flip-flops tied together like this and 1 flip-flop in isolation. So that is why there are 2 clocks, okay. So clock 1, I think it is saying clock 0 and clock 1, something like this. So I think from that nomenclature you can make out which one is what. So for one of this clock, I mean clock 0 and clock 1, you may find out which one I'm talking about. So that is just going to a lone flip-flop which is not connected to anything else inside. Maybe other than the reset pin is connected to that, that is the common thing. But other than that, so far as the clock and outputs are concerned, it is not connected to anybody else. Whereas there are 3 flip-flops in a chain The other clock is feeding this first flip-flop and rest of them. So you can use it as a 3-bit separate counter rather than a 4-bit counter without even involving it. Whereas you can use this one alone, just like a 2-bit count. I mean, sorry, a single-bit counter that suppose clock and A, whatever I have drawn. If you think this output as A, so whatever is the clock frequency, it will divide it by 2. So it can divide the clock frequency by 8, whereas it can divide the clock frequency by 2. Now for 16 state counter or 4-bit counter, the natural connection that you may require is, as I think your friend has just now suggested, that C is connected to clock. So then it makes a complete chain. So that is what is being required. But I may suggest an alternative. I may say that, okay, I will apply the clock not here. I will apply the clock here and connect the D output, this output. Maybe I can change the nomenclature of that. I can put this output to this clock. So whether do you think that will make a 3-bit, 4-bit counter?
Yeah, then D will become LSB.
But in that case, D will become LSB. Okay. But you can really do that. Only thing is that the pins which are connected where you need to take care of that. That if you apply the original clock here, then this one will become the LSB. This will become MSB, provided that you have connected C to this clock. Otherwise, this won't respond. Alternatively, I apply the clock here. This becomes the LSB. This becomes the next bit to the LSB if I connect this D input to the clock. But that connection is necessary. Okay. And then I'll be putting it over here. Now, I think whoever has shared that screen or otherwise also, if you can just tell me in that 7493, whatever is given in the simulator, what is the name given to the input of this clock and the other clock? And rather than ABCD, they are calling it Q0, Q1. So which one is what? So if anyone is once again having, if you wish, you can share once again the screen. If possible, please share, because
Yes, sir.
I'm running 2 windows. I don't want to disturb that.
Yes, I have shared.
So now from that, will you be able to identify?
Yes, I think this Q1 is going, this one is the D that you have made, and then we are connecting this to others, ABC.
Okay, can you come once again?
So what I think is this is being connected to D, then it is further being connected to the ABC.
Right. So CP0 and Q0, they are actually that lone flip-flop. So you are giving the clock to the lone flip-flop. The output of the lone flip-flop, now you are giving it to the next clock. And this is the other 3, that is Q1, Q2, Q3, is basically whatever I have called ABC. Okay, so it is just the other way around, that Q0 is D, whatever I have, so that is a lone flip-flop. So that connection is necessary, otherwise it will not form that thing. Okay.
Sir?
Yes.
Sir, means why we are like connecting the flip-flops in this manner, like 2 separate clock inputs? We can like easily connect 4 flip-flops in a row and give only one. Like
actually, in many cases, people are finding that, okay, they require only up to 8. So some octal combination or something it is called. So they do not require 4-bit full-fledged counter. So in that case, they do not require to unnecessarily waste that power over there. They can keep the clock connected to ground. So there will be no change in the state of the clock as well as the output. So they can use it as a 3-bit counter without involving the 4th one. So that is the motivation behind this. So just I think the other Windows is facing a little problem. Okay. So here.
Excuse me, sir. So can you repeat it? What is the need?
The need is, I think my, so please unshare the screen and then I think, so I think once again my document is visible in that case. So in some cases you may find that the requirement is to have an octal counter. Octal means there will be 3 bits. It will go up from 000 to 111. You do not require the 4th bit. So in that case, you can actually use only this chain of 3 flip-flops, applying clock over here and getting the 3 outputs. And at that time, you do not apply a clock here. You can put a ground connection to this clock, so the clock becomes invariant. So the output will also not change. So this one will not consume any power in that case. Otherwise, if you have connected it in a 4-bit chain, suppose you are ignoring it, but still it is changing the state from 0 to 1 and so on. So it will consume a little bit of power. Sometimes it may generate a glitch also if you are not using that one. So unnecessarily the output is changing. So just to have from that motivation, people are using it. But the other provision is also there that you can connect it and simply use it as a 4-bit counter. So both the things are possible. But now I think I must say about for 7490. So can you emulate the behavior of a 7490 using a 7493? What I mean, 7493 counts from 0 to 15. But I want, suppose, the display to go from 0 to 9 only and then reset back to 0, just like the behavior of 7490. So is it possible to activate those resets somehow so that it won't go beyond 9 and it behaves just like your 7490 decade counter or so-called mod 10 counter? So my problem is to modify this counter into a mod 10 counter. So can you suggest something? Maybe some of your
we add Q3 and Q1 and connect it to the reset.
You add Q3 and Q1 or
We AND.
okay. So let us look into the solution, whatever you are suggesting. So I'm just writing that part, that where it is going from 9 to 10. So this is 9. We are calling them, I think, A, B, C, D. You may call them Q0, Q1 also in whatever way you are connecting. So then it would go to 10. So if I do not try to reset that, it will go into that A, B, C, D, E, F, I mean this hex character I'm talking about, and will display those peculiar character like C, inverted C, and so on. So then it will go up to all 1, and then only it will reset internally. I mean automatically it has to go to 0. Now whatever I think your friend is suggesting, that if I go by this nomenclature, then what are the two outputs you would like to AND?
B and D.
B and D.
B and D. So the motivation behind this one is that whenever it is changing from 9 to 10, so if I activate this AND gate, I mean if I put it like this, so then it will generate a reset signal, right? That as soon as it becomes 1010, so B and D, this is the first occasion when B and D is going high.
Sir, can you scroll your page?
Oh, okay, sorry. My camera setting needs to be changed a little bit. Earlier I used to see almost the whole paper. Anyway, so here this, just let me check the other window whether they can, yeah, that's. So here, this is the first occasion when B and D both are becoming high, right? In earlier cases, B and D is never becoming high because this is the first occasion when you are getting 10 and it increases monotonically. So when B and D they become high, then the output of the AND gate becomes high. So where do you like to connect this output of the AND gate?
To reset.
To reset pin of 7493. So that will actually skip all these states. But in that case, whether this state 10, that will also come. My intention is to get 0 to 9 only.
Yeah, for a small time instant that would come.
Yes, it will be a very short-lived state. So how much would be the lifetime of that state?
Equal to the AND gate delay?
Yeah, equal to the AND gate delay plus the resetting there might
plus the reset delay, yeah.
Also a delay, but that will be much smaller compared to your typical clock period. Suppose if you are using it for a real-time watch, real-time clock, then maybe you are changing it in 1 second or so. Okay, so you may find that, okay, all the states 0 to 9, they are staying there for 1 second, whereas this is happening maybe in hundreds of nanosecond or maybe even less than a millisecond. Okay, so so far as the human users are concerned, so you do not face any problem. Only thing is that if you are having some, I mean, in a persuasion of automation, suppose you do something, then there could have been some problem. So I'm coming to that one. Okay, I think since I've mentioned about that, otherwise I'll forget. So just I'm posing a problem to you. Suppose forget about this resetting as such. Suppose I am having a decade count, not a decade, that binary counter. So binary counter starts counting from 0000, goes to 0001, then goes to 0010, then goes to 0011, and so on. Okay. Finally, it will. Let me write another one, and it will go like this. So after some time, I know that okay, it will reach 1111, and then once again it will go to 0000. So suppose I want to trigger some event periodically, that whenever the counter reaches 0000, I would trigger some more events. So I would like to design some block that will check whether all the bits are 0 and would make the output high for this period only, as long as they are 0. Once again, when it becomes 0001, that will fall. So can you suggest any circuit for that will test the output, whether the counter 4 bits are, all the counter outputs are 0, and then
NAND gate, sir. NAND gate.
Just verify once whether NAND
Sir, OR gate.
NAND will actually capture when they are all 1, then it will become 0. But I require the other one, that when they are becoming all 0, it should become 1. So then
Sir, NOR gate.
It should be the NOR gate. So the 4 inputs A, B, C, D, I can put on a NOR gate. So what is my expectation? That it will give a pulse for maybe 1 second, if I assume that okay, they are staying here for 1 second. So I will be having a 1 second wide pulse whenever it is crossing 0000. Again, I will get a 1 second wide pulse when it is. So how much should be the gap in between two zeros and two high pulses? How many seconds? The counter runs in a clock with a 1 second period.
16 seconds, right?
It repeats on 16, so 1 second it is staying high. So maybe this low time will be 15 seconds.
15 seconds, right?
What is expected. But you will find something unexpected here. You will find that okay, may not be 1 second wide pulse, but there are some more pulses appearing in between.
Yeah, those will be due to glitches, right?
But where from that glitches may come?
Due to the delays which are in there.
Right. So this is called an asynchronous counter. Once again, I think it will be discussed in the theory class. But just since we are mentioning about that, so because we have already mentioned about this flip-flop structures, so the clock comes here after one flip-flop delay, because there will be some delay associated with such circuit. Then only this change will take place. And only when this change takes place, then only it can react to that. It will take its own time, own delay time to change B. Then C will change after another delay time of this flip-flop. So the change from a particular state to another state is not instantaneous. So A, B, C all are not getting changed simultaneously. A is changing first, B will change later, C will change even in another delay time after. Delay means that flip-flop delay. So whenever suppose I am talking about say state change of 0 to 1, this will be undisturbed because there is just one flip-flop changing its state, but the next state you see both of them are changing. So what will happen? Whether if I write A, B, C, D, whether A and B both will change simultaneously, or there will be that will be done in sequence.
B will lag A, C will lag B.
So first thing what will happen, A will change from 1 to 0. That will actually gives rise to a falling edge, which will trigger the next event. So there will be a gap. So A will change first to 0 before B changes to 1. So then there will be a spurious state. What will be that spurious state? C and D remains 0, so there is no issue. B is still remaining 0, but A has already changed to 0. Right? B is yet to react. So there will be a spurious state here. Will there be any spurious state between 2 and 3? No, because just
no.
one flip-flop is changing. But here there are 3 flip-flops changing. One becomes 0, this one becomes 0, this one becomes 0 to 1. So what will be the spurious state here? Can you just identify and tell me?
One will be 0010.
First 0 0 1 0, because this one will not change immediately, but this one would change. So 0 0 1 0,
and then 0, all 0.
then all 0, because then this one will be changing to 0. Still the flip-flop in the third position, it has not changed to 1, it is still 0. So once again you will get 0 0 0 0. Then the third flip-flop changes, it becomes 1. Okay, so now here as you can see that we were expecting only here and here the output of this NOR gate will become high. Now it is becoming high here as well as here. So in between you will find, so will there be more glitches? I have shown only between 2 and 3 and 4, 3, not 2 and 3, 1 and 2 and 3 and 4. So there will be some short-lived glitches. What will be the width of these glitches? Much shorter than this, right?
Right.
So what will be the width? Who will decide?
It will depend on the propagation delay of the flip-flops, right?
Yes. So it will be the delay of the flip-flop. So there are actually different delays. It may not be actually called a propagation delay. It is sometimes referred as clock to Q delay, but as you have right, so it is something equivalent to a propagation delay in a combinatorial circuit. So you will get more glitches, right? I have only shown 2 occasions. There will be more such occasions where there will be glitches. So I think I may not spend time on that. But right now, let us come back to our original business. We are talking about resetting it so that 7493 behaves like a 7490. Okay, so how do you do that? You said that, okay, you will be using an AND gate. So now I said that where the output of the AND gate will be connected. So in the 7493, as I have already mentioned about 2 pins, so where should I connect it? Should I connect it to pin number 2 or should I connect it to pin number 3? Any suggestion? Please unmute, otherwise I feel that, okay, my voice is not reaching you.
Sir, what were the pins 2 and 3 again?
I said that I once again I forgot, or rather could not identify who has suggested that, maybe Shivam or somebody else, that I should use an AND gate where B and D will be ANDed, and the output of the AND gate, I was asking that where should I feed the output of the AND gate, because this will become high once that counter reaches 10. Now I need to reset it. So for resetting, what will be the exact connection? Should I connect the output of the AND gate to pin number 2 or pin number 3, because there are 2 reset pins?
The one which makes it 0.
No, I think both. It is that the condition is when both of them are high, then only it will be reset.
But sir, one is already grounded, right?
No, may not be. That depends on how you are. Because if one remains grounded, it can never be reset.
Yes, sir. Then how will do it?
So you connect the output of the AND gate to both of them, tie them together, and both of them. So when the output of the AND gate is low under normal circumstance, 0 to 9, so then it feels that, okay, as if it is grounded, and then it runs properly. Now when that output of the AND gate becomes high, so then both the input becomes high, and it will be reset. So does it appear to be a feasible solution?
But sir, earlier you mentioned that to work it at the normal operation, one should be low.
Normal operation means, what is the normal operation of 7493? Normal operation is 0 to 15, it will count. We don't want it to have normal operation.
So what is an abnormal operation then?
Come once again, I could not follow your question.
If when both are high, then it is reset. If one of them is low, then it happens to be a normal operation. If both are low, then what happens?
No, it is something like an internally ANDed. Okay, this pin number 2 and 3, as if they're internally ANDed to generate the internal reset signal. So the functionality is like this: if both are 0, nothing will happen. If one is 0, the other one is 1, nothing will happen. If this one is 1, the other one is 0, then also nothing will happen. Nothing means it counts normally. Only when both are high, at that time, all the flip-flops will be reset.
Oh, so got it.
Got the point?
Yes.
Okay. But here, I mean, why I'm emphasizing this and spending time also, that do I really require the AND gate? What is the purpose of the AND gate here? You have asked me to put an AND gate. I have drawn an AND gate connecting B and D together. So what do you think is the purpose of the AND gate?
Check when both B and D becomes 1.
Pardon me?
That's to check when both B and D becomes 1.
Right. And then what I have.
So we can directly connect B and D to 2 and 3, right, respectively?
Yes, yes. So that is what actually I tried to find out, but tried to get the answer from you only. That I really require, I mean, I do not require that AND gate to be used explicitly because that AND gate is already inside. And that is why I think 2 reset pins are really available. Otherwise, they could have made just a single reset pin available. So I do not require any extra component for some such resetting purpose. So as soon as this B and D both are high, so if I connect, once again, let me, okay, it's already visible. So if I connect these 2 and 3, these pins, that are reset pins, one of them each either to B or D. So one of them goes to B, another one goes to B. Then when both are high simultaneously, that is the moment when you want to capture this by this AND gate, that will automatically happen. Internally there is an AND operation. So now, can you tell me, suppose somebody mistakenly has connected D and A rather than D and B, thinking that, okay, I do not require the 10th state, so I require only up to 0 to 9, so it should reset when it reaches 9. So then what will happen if reset pins are connected to D and A?
It will like count to 0, count to 10, and then get reset.
No, A and B count up
It
to
will, so we connected A and B or A and D?
A and D for Delhi.
Oh, it will be a mod 9 counter.
It will be a mod 9 counter. So all of you agree?
Yes, yes.
Yeah.
Good, right.
Right. So as soon as 9 will be reached, it will be very short-lived state, equivalent to the delay of, now there is no AND gate, right? So it will be essentially the internal delay for resetting. So how much is that? So after that, so can you just tell me, maybe for your convenience, I can just spend half a minute to write down all the state from 0 to 9. 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, 1, 0, 1, 0, 0, 0, 1, 0, 1, 0, 1, 1, 1, 0, 0, 0, 1, 0, 0, 1. Then I think it may get reset, but if it is not reset, then we know that, okay, it will generate the others also. So just let me write all the 16 possible states. 1100, 1101, 1110, 1111. I think the whole set is visible. Okay, so now I have already shown, or you have also suggested, that I can have mod 10 counter, I can have mod 9 counter. What are the other things I can have? Can I have a mod 3 counter? That it will start with 0, it will go up to 1 and 2, and then it will reset.
Yeah, like
Yes,
A
sir,
and
we
B.
connect A and B.
Let me write that A, B, C, D. So if I put A and what else you said? B. Right, so when it reaches 3, it will be reset. So 0, 1, 2, there will be 3 states, so it will be a mod 3 counter. What about mod 4 counter?
Yes, sir, connect to C.
So how do I get a mod 4 counter?
So take the connection from C and put it to reset.
Okay, so just think about this. Your answer is correct as such, but think about when I say I require a mod 4 counter, so what is the functionality I need? What will be the output I will be requiring from a mod 4 counter? Equivalent states of 0, 1, 2, 3. Right? After 3, once again I require 0. So is there any other solution whatever you have suggested. You suggested C to connect. C, where should I connect?
So to both the resets.
Okay, both the resets, so it will work certainly. But other than that, anyone can suggest any other solution? Let me
So
give
maybe
you-
you can use the rising edge of the C. Or can we do that?
No, but there is a simpler solution. When we say mod 3 counter, sorry, mod 4 counter, how many bit output I do expect when it is having a state of
2-bit.
2 is enough.
2 bit only?
Right.
So I can simply ignore that C and D. If I require 4 bit, I can just take that from the ground connection rather than taking from C or D. I will simply take A and B. I will not reset the counter at all, because if I just hide this C and D portion, you see, you look at B and A, it is going like this. It is getting reset after 1 and 1, right? It is going to be 0, 0. Once again, when it is reaching 1, 1, it is coming to 0, 0, and so on. Because that modulo, I mean, whatever I am saying, modulo 4, that is power of 2. So same thing will happen for modulo 8. So what do you do for modulo 8? 0 to 7?
We ignored the last bit.
Ignore D.
You just take the lower 3 bits, and that is what I think in this particular 7493 you can actually, you need not have to connect the other flip-flop also. You can simply connect the clock to the so-called clock 1 and take the output from Q1, Q2, Q3 rather than using Q0 and clock 0. Directly you can use it. But even if it is 4-bit circuit, suppose some other IC is having you all 4 bits, you can ignore that 4th bit and just take this 3-bit. So you do not care whether D is going from 0 to 1 or something. If you require a 4-bit output, connect the other output to the, I mean, not connect D to the ground, but wherever you are using that 4th bit, you take that connection from the ground. So that's all. So power of 2 is simple, but other than that, so 4, 8, if it is power of 2, then there is no issue. But other than that, what are the other modulo you can realize? You said that modulo 9 is realizable, modulo 10 is realizable. Can you just look into this and tell me other things? So certainly modulo 8 is realizable because it is power of 2. Modulo 8 is realizable. Modulo 4 is realizable. So then modulo 2 must be realizable also. What is mod 2 counter?
We just take the first bit, only one flip-flop.
Only one flip-flop. So if you really require that, you do not require even the longer chain. In a 7493 you can actually use, because in some case you may need to divide the clock by 2 for some purpose. You do not require this chain to be used. You apply it to Q0, clock 0, take the output from Q0, connect Q1 to ground, then none of them will change. So that's fine. So can I have mod 3 counter? I think mod 3 I just asked you.
Yeah.
Yes.
Right, mod 3 you said A and B need to be connected together, mod 3. So mod 2, mod 3, mod 4 done. 8, 9, 10. In between mod 4, 5, 6, 7, can I do all of them without adding any extra gate? I think this is not visible. Let me put it here.
5 and 6 we can do.
We ignore D, like.
Mod 5 and 6 you can do. What about mod 7?
Seven we would require an external gate.
Right, 7 you require because there are 3 bits need to be captured when it reaches 7. So 7 is not possible without adding anything else. So you can have mod 3, mod 5, mod 6, but not mod 7. Okay, 8, 9, 10. Now what about, suppose you require for some other reason, modulo 11, 12, some such counter, not just for counting purpose, maybe for some other reason. So then looking at that, can you tell me what are the other modulus that you can realize? Modulo 11, is it possible?
No, sir.
So can you repeat that modulo 7?
Modulo 7, if you require, that means when it reaches 7, you need to reset, right?
Yes, sir.
So then A, B, C, you need to capture 3 of them, but the internal gate is having only 2 inputs. There are only 2 reset pins. So you cannot connect 3 pins into 2 pins. You require at least one more gate, maybe a 2 input AND gate, so that you can connect them to reset properly. When all the 3 bits are high, then only that will be reset.
So we can use external 2 AND gates and put it to into.
I'm saying without using extra gate, what are the modulo you can realize? Certainly, you can always use extra gate. So just can you quickly? I think we may not spend much time on that. This is something very trivial and should be done on the sideline itself. So I was asking modulo 11. Can I realize?
No, sir.
No, because once again that requires three bits capturing. But modulo 12, then I must be. Should I write modulo 12?
Yes.
What are the things I need to connect to?
CD.
Huh?
CD.
CD. Okay. So any other modulo like 13, 14, 15, can I realize?
No, sir.
No, sir.
No, without adding extra component, I cannot. And the counter itself is modulo 16. So I think this writing is needless. That okay, I can have modulo 16 also. Modulo 1, does it have any meaning? Because I have started writing with modulo 2, just it came to my mind that whether I should include modulo 1. Is it trivial or is it meaningless?
Like only the clock pulse will be enough.
Fine. Now, a little bit about 7490, because all these things I have said. So unless I spend another say 4 or 5 minutes on that, maybe at later point of time while using 7490, you are having some doubt and you may have problem in that case. So how do you think 7490 is has been designed? You already know about this resetting. So 7490 must also have 4 flip-flops inside, right? Otherwise, 4-bit output it cannot give. And but it is getting reset at that so-called 10. I mean, it is giving you only up to 0 to 9. So do you think internally there is some reset mechanism for that? And if it is, then what should be the resetting mechanism?
So they have like AND gates to like count up to 10.
Okay, so count up to 10. That means when your what do you call that? B and B. What are the signals we have identified? B and D, right? When B and D, let me put it here. When B and D they are high, then it will be reset. So think about flip-flops. I'm just drawing it over here once again. So I am having 3 flip-flops. Now, as per their terminology, it's not visible, I guess. As per their terminology, where should I put the lone flip-flop? On this side, that is on the LSB side, or on the MSB side? They are calling it.
Depend on the connections.
No, I mean then certainly, but as per their nomenclature, they are calling it Q0, Q1, Q2, Q3, something like that.
If it is Q0, it should be on the right.
It should be on the LSB side, right? Means LSB
Yeah.
side, right? Okay. So I'm putting that over here, saying that this is my Q0, this is my Q1, this is my Q2. So going by their nomenclature rather than ABCD, then I think maybe I can draw the clock also. This clock is not connected. So these 2 clocks are separate. This clock is called CK1 or CP1, I think, in that simulator. This is called CP0. So it is like this. So we need to make an external connection from whatever be the pin numbers from Q0 to this clock, so that it can be tied together as a 4-bit chain. And the reset mechanism, so can you just tell me from which 2 outputs I am supposed to take the reset connection right now?
CP1 and CP3 means B and D. Like.
No, as per the nomenclature, there is no CP3. So do you think I should connect it from here or somewhere else? Just
Q3 and Q1.
for the sake of understanding, I'm putting ABCD over here. You said B and D, right?
CP1 and Q3, I think.
No, CP1 is here. Do you take the output from CP1?
So we take Q1 and Q3.
CP1, I think who was telling
Yes, sir. Q1 and Q3, sir.
Right, Q1 and Q3. Okay. So Q1 and Q3, maybe I can use a different color. Q1 and Q3. So this I am having that reset mechanism. So there was already that AND gate kind of thing. Earlier that AND gate was connected only to the outside, but right now that AND gate is connected here also. Technically, I think the actual design is somewhat different, but technically as if we are having an, is it visible? As if we are having an AND gate that will reset, but I have to accommodate the external reset pins also. Okay, so there might be some ORing or some such thing is there. So I'm not showing that much of details, just as a logical one. So now you see, this one is going to the reset pin always, so it will act as a mod 10 counter. If I connect it like this, it will act as a mod 10 counter. So I think there is no question up to this point. That, we can understand how it is happening. Now my question is, for 7493, let me show you that figure once again. I have drawn 3 flip-flops together and a lone flip-flop here. I said that, okay, you can connect it here or you can connect it here. It won't make any difference. Okay, only thing, any difference means in the final output, as long as you are consciously applying the clock to proper place. Either you have to put the clock here, call this one as LSB, or else you need to put the clock here, call this one as the LSB, then you need to make this connection, this one becomes next to LSB, this one becomes MSB. Alternatively, this is the clock, this is the LSB, you make a connection from C to this clock, this becomes MSB. So both are possible. But here, in 7493, is it possible to interchange the position of this flip-flop? That one, certainly I can connect Q0 here and get the output. But if I apply the main clock, the primary clock here from outside, and connect this CP0 from Q3, just like 7493, as we have said that either I can connect this lone flip-flop on this side or on the other side. What will be the consequence, or what will happen if I put the lone flip-flop on this side, connecting Q3 to this CP0?
Like then it will like to the AND gate Q0 and Q2 should be like given it.
So then what will be the modulo of the counter? Or it is, so can you just spend 1 minute with your copy and then look at that and then answer?
Mod 5 counter.
Your voice got
So
choked.
it will be mod 5.
Mod 5.
No, it will be mod 5 only for this portion. If I take only this 3-bit, suppose I do not use over here, then it will be used as mod 5.
So will it be a biquinary counter?
Yes, that is called, I do not know whether you are aware of something called a biquinary. You know what is a biquinary thing, all of you, or?
No, no sir.
No, so
But anyway, at least we can find out what will be the sequence. Suppose if I completely ignore this one as if it doesn't exist, then I think there should not be any confusion in this 3-bit output. What will be the 3-bit output? On reset, it starts with 000. Then it will go up to how much? Think about mod 10 counter when it is getting reset, when it is reaching 101, right? B is becoming 1, this is 0, this is 1. So then it is getting reset. So now as soon as this 3-bit counter reaches 101, it will be reset. So 101 will be the short-lived state. So what will be the modulo of the counter now? It starts from 0. Think for a minute and then tell me.
5.
Modulo 5, right? So as soon as it reaches 5, it will get reset. So 0, 1, 2, 3, 4. Then on 5, it will reset. Once again, it will generate 1, 2, 3, 4. Then becomes 0. Then from 0 goes to 1, 2, 3, 4 and so on. But now while having that, if I connect this Q3 to this CP0, what will happen to this Q0 output at that time?
So like, can you repeat your question again?
Okay, let me draw a fresh figure. So hope that you do not have any confusion about the 3 flip-flops when they are in cascade, along with that reset at resetting business. So then it is connected like this. This one is connected like this. I am having these 3 pins. They are called Q1, Q2, Q3. This is called CP1. And now I'm putting the 4th flip-flop here. I'm putting the 4th flip-flop here. So essentially connecting the so-called CP0 here with Q3. And the output of this one is Q0. But now I'm putting Q0 as my MSB. I'm taking this one as LSB and Q0 as my MSB. So then what will be the output? Initially they were all 0, 0, 0 because of reset. So now these 3, because I am applying clock pulse over here, this one will change first. So this keeps on counting 0, 1, 2, 3. Should I get 4? Say yes or no.
Yes.
Should I get 5?
No.
No.
Because after
You
4,
will get 8.
there will be a short-lived state of 5, but as such it will be reset to 0. So if my clock period is 1 second, so maybe for a few nanosecond I will get few hundreds of nanosecond, I will get that 5, then it will be reset to 0. But what about this Q0 bit? Q0 will remain 0 throughout. First change, it is getting a rising edge 0 to 1. So should it change?
For 1 to 0 it will change.
Right, for rising edge it should not change, so it should remain 0. But immediately after another clock pulse, because of that reset mechanism, it is falling. So that will give rise to a falling edge. So then it should change, right? So it will change to 1 and it will remain 1 for how long? Once again it will keep on counting 0, 1, 0, 0, 1, 1, 1, 0, 0. Yes.
So is Q0 connected to is CP0 connected to Q3?
CP0 connected to Q3, right? I have done external connection.
But sir, when it is like resetting, wouldn't Q0 be 0 too?
Yes. So if I reset this, so what will happen? This one will become once again 0. Right?
Yes, I feel it should become 0.
So then it would become something like a mod 5 counter only. And as we have said something about the biquinary counter, what is the biquinary sequence?
So 0 to 4 and then 8 to 12.
0 to 4 and 8 to 12. Okay. So somehow, if you can stop this flip-flop from resetting, right? If you can somehow stop this flip-flop from resetting, so then are you getting this one? Because in that case, it should remain like this. And then only that next time when there is a falling edge, it should change. So it is counting from 0, 1, 2, 3, 4, then jumping it to 8, 9, 10, 11, 12, then coming back to 0. Okay. So just think of, I mean, you cannot really think of and find it out. So you need to just go through the manual that how the reset connection is there inside a 7490.
Sir?
Hi, yes.
Sir, like after counting to 4, how will the output of Q0 like go to 1? The resetting will not, won't it set all the outputs to 0 like?
No, that is what I'm saying, that if, because I am saying that 7490 is having some additional resetting mechanism also, right? That set to 9 or something. So just look at the manual, because then you know that, okay, how to go through a manual. Suppose my intention is to have a biquinary counter, as I think your friend has suggested that maybe it would count like a biquinary. So looking at the manual, can you conclude that, okay, is it possible to have a different reset mechanism for this one and this one? Okay.
So where do we get the manual?
Just you try to download that 7493 data sheet. So whenever you try to download, you need to give that number followed by that data sheet. So then, sorry, this is 7490. 7493 also you would download. 749 data sheet. Acha, just one thing, I think maybe that one actually give you the answer if I say that, but still I think otherwise if you so when we say that you require a reset at 10 because this is a decade counter, right? We said that okay, Q0 you are putting over here and you are having a decade counter. Then when you have connected this so-called D and B, that is Q1 and Q3 to maybe an internal AND gate, and then you are activating this resetting. So this resetting, what are the flip-flops do you think you need to reset? Do you need to reset all the flip-flops or direct, I mean, somehow they are getting already taken care of, that you need not have to connect this to the reset pin of all of them? What do you feel to make it a mod 10? Mod 10 is something like this. I should take it here, that as if B and D. So next clock pulse that is coming. So what are the flip-flops you think you need to you need to
Can only reset B and
Only
D.
Q1 and Q3, I think. You don't need to like take care of resetting all the other people because they are already zero.
Right. So probably the hint is loud enough that it may so happen, but still I would ask you to just check that it may so happen that this internal signal may not require to reset this Q0. It is only acting either on two of them or maybe to three of them. Okay, that may happen. So if that thing happens, then but still this flip-flop you can reset from the external pin 2 and pin 3 always. But it need not happen just because of that internal reset, because here as you can see that it is automatically from 9 when it is going to 10 or 0. In either case, it is automatically going to 0. So I may not have to have an explicit reset in that case. So please check the manual or the data sheet. So have you seen data sheet of any stuff maybe for analog? I do not know, for the transistors. Have you downloaded the data sheet and seen by any chance? Or for any other digital circuits?
No, sir.
So like in TNRTI, which we did in last semester lab class, they have like data sheets. Like if we type, there is data sheets of Texas Instruments of that particular like component. I don't know about this like circuit maker.
But anyway, I think you can download from the, I mean, obviously a trusted website, not something else. So if you look into that, so just if you, let me see whether I am having a data book with you. Just wait for a minute. If I can find a data book, I will show you a hard copy. Just one minute. Yes, so this is, I think, an old data book of because similar IC, I think different manufacturers manufacture. So this is a book from National Semiconductor. You can get similar thing from TI and others also. So they are typically all giving the same number, 74. For example, here we are talking about 7490 or 93. Sometimes there are something, maybe say some people say CD 7490, some people may say SN 7490. So there might be some manufacturers alphabetic code somehow. So just whatever we are saying, so let me put into that. Okay, so if you download, you will get the exactly same PDF maybe. So here maybe so it says that, okay, so in this case DM, that is something like I think once again it will be discussed in your theory class. Don't get bothered about this. In between there is something that LS is written, 74LS90. This L stands for low power, S stands for short key. I do not know whether you are aware of what is called short key. By any chance, do you know what is a short key? I mean, where, in what connection that word is used, or that's the name of a scientist anyway. But what is a short key? A short key barrier, short key diode. Have you heard about that one anywhere?
Yeah, we heard about Schottky diodes.
But the name is not.
So it actually having some faster operation. So I'm not once again going to the detail. So in theory class, I think it will be taken up. So here I think in this manual, maybe I can get without this LS also, but just I'm showing about this. So initially it is showing all these pin diagrams, as you can see that this is, but the nomenclature is somewhat different from that manual, what do you call that, simulator. Simulator, for example, that input here, it is calling input A and input B, these two clocks. Whereas there, they are saying it input, what is that? Clock 0, CP0 and CP1. Here they are using that type of nomenclature, QA, QD, QB, QC, whatever I was referring as ABCD, something like this. And in the simulator, they are calling it Q0, Q1. So there are different nomenclatures, but as such the things are same. And whatever I was drawing, if you, right now I think you need not have to bother about the rest of this. For example, it is saying that switching characteristics, that what is the, can you read, is the focus okay, or?
It's blurry, sir. It's
unreadable. Can you send the photos?
No, I think you can download the PDF. Eh? Just one moment. Let me see what is the setting in my video send resolution. It says auto, so maybe send resolution is high definition. Okay. So anyway, don't bother about that. It says, for example, T max. What is the maximum frequency? Sorry, F max, maximum clock frequency. It says you can use it for 32 megahertz. So these are something which right now you may not require, but a datasheet would give all these details. But what we are looking for, maybe these are the diagrams that I think I was showing to you. So this is that 7493, probably you can read also. There are 3 flip-flops in a row whose outputs are connected to the clock of the next one. And this is that reset line is showing with a NAND gate. It's not a AND gate, it is NAND with active low reset pin, and this is the lone flip-flop. Okay, so the other one, as you can see, that it is having slightly different configurations. That it is having this in the reset, they are showing some gates, right? And why these gates are needed? Because they can be activated either internally or externally. There is this external reset with that NAND gate that is used in 7493 also. So either it will be reset on the influence of the external reset pins or that internal mechanism. Just now I think as we are explaining that when it becomes 101, so this is the lone flip-flop. So I do not find any reset connection, any gate or anything over here. It is just simply connected to the external reset. So just now whatever I was suggesting, that maybe that lone flip-flop is not, I think it is not visible. Lone flip-flop may not have a reset internal, so maybe that could be true. But still you may just check it up. Okay, and that is the other reset when it says that, okay, it can be reset to 9, that RS or whatever you were saying. Okay, so, okay, maybe I can stop at this point. So once you download this simulator, the idea is very simple, that you can find out, you can make a real-time clock showing just say hours and minutes. So it should have 4 displays. That is your first experiment. You can get almost a week's time. From next day onwards, you have to carry out the experiment during the lab hour, and then so that will be the display. And here 7447 will be connected to each of them. 7447, 7447. So I am not drawing all 7 connections, I am just showing it with a wide arrow. And certainly you require resistors. In simulator you cannot really blow up any IC or anything, it won't burn, but it's a good practice to do whatever you are supposed to do on the lab. So use proper resistors, 330 ohms or whatever. The default is 1K. Even if you put 1K, I think in simulator it would work. So now you are having 4 digits and 4 inputs possible. You may later on say that, okay, if you like to change one of them, for example, it may not be required if you need something like a 12-hour clock. So a clock, a real-time clock that displays time, what it should be reset to? If you reset a clock, what it should reset to? Should it reset to 0000 or something else? Anyone can say?
So like it will show hours and minutes also, like the clock that will.
Suppose hours and minutes. You can even put the seconds, but that will just two more if you wish you can add. But just now I'm saying suppose hours and minutes. These are HH, these are MM minutes. If it is
So like the minutes will like change to 0, but the hour will change to like after 12, after counting 12, it will like change to 1.
right. So I think maybe a 24 hours clock will be easier to design first. So I would request you to design first a 24-hour clock. So for 24-hour clock, I think it shows 0000, right? When it will show 0000? The 24-hour clock?
At midnight.
At midnight, exactly. So then it's keep on counting, but you have to be a little careful that when it reaches 0059, what will be the next state?
0060.
01.
0100.
0100. Okay. So taking them together, what is the modulo you need? If I take this thing, I can say this is a modulo 60 counter, right?
Right.
But can I realize it using a mod 10 counter in the LSD? I'm saying LSD, least digit, least significant digit. And the next digit I will use a mod 6 counter because it is counting from 0 to 5. Will it work?
Yes. It should work.
Okay.
So like can you explain again what you said?
I said that if I individually, I said that, okay, taking them together, minutes together, it is becoming something like a mod 60 counter. We know that, okay, minutes we count in modulo 60. But can I realize it using two individual counters? One is working with mod 9, mod 10, another is working with mod 6 because it displays from 0 to 5 only. But then the question is, who will supply the clock to this? Clock to the second one. The first clock anyway is a I am assuming that, okay, I can design a clock signal with 1 minute time period, and that one will trigger this first digit. Who will tackle the second digit? So I must be having some sort of counter in each of them. You may use 7490, 7493, or whatever, a combination of them as you may need. Only restriction is there should be 74 series ICs right now. Later on, we can remove that restriction also if you wish. So my question is, can I realize it? This is very easy to realize a mod 10 counter. Either use directly 7490 or use 7493 with BND connected. Yes, any questions?
So, what is the frequency of the clock that we can use?
Frequency of the clock here, because I am using this one, is the changing it the fastest one. So after how much time do you think I need to change this?
It should be like the time period should be 1 minute.
Time period should be 1 minute, exactly. So between two, if I assume they are acting on falling edge, between these things, two edges, it should be 1 minute. So I need to design a square wave generator circuit with a time period of 1 minute. So I provide that. But then the question is, what will be the, I mean, who supplies the clock of this? Where from I will derive the clock?
The output of the first counter.
Output means outputs are actually going over there. There are 4 bit outputs are going over there, and output is going.
So when that would be reset, basically.
So output is going to be reset after 9, basically, whenever it reaches 10.
You can just use the MSB, the first counter.
Okay. So let others also figure out that one. So successively, I think you can think of the only, I mean, it should not be a challenge, I may say. It is very simple, but just let us keep it simple at the first experiment. So where from you will generate this clock? That is the first thing. So if I formally state the problem, that first thing is design a 24-hour clock. Clock means real-time clock. I'm not talking about a clock signal. Okay. I may mention sometimes it is called RTC, real-time clock. Assuming that there is a 1 minute pulse available, I mean pulse with time period 1 minute, and then modify the design, or I can say that could be a separate design altogether. Design a 12-hour clock. So 12-hour clock is slightly tricky. Why? That is also real-time clock. What makes the 12-hour clock a little more complicated?
Like after counting to 12, it will like change to 1. Like
So reset, I think a 12-hour clock will never show you 0000, right?
yes, sir.
So 12-hour clock, it starts typically on reset. What will be the value?
1200.
1. It depends actually on you. Either you can reset it at 12, and many real clock they reset actually at 0100. Okay, so whatever you wish, either one is acceptable. But when it actually works at that time, you should see that it should get reset after 12:59. That is the most important thing. After 12:59, the next value should be how much? 0. You can suppress the 0 if you wish. You know how to suppress that 0? There is actually something called a blanking input in the IC. I do not know whether in simulator it is working. Last time I think some people have complained that 7447 that blanking input is not. But anyway, we don't mind having a 0 over here. But it should be 12. But do you think if for a 12-hour clock, what are the states of this output? And what are the possibilities of having it here? I can either have a 0 or a 1, right? Nothing else. So for that one, do I really need to spend a full-fledged 7447, or I can do it in some different way? Similarly, do I require a full-fledged 7493 or 90?
You can just use a simple flip-flop.
But anyway, since we are using 7490, maybe that only, or 7493, only that lone flip-flop you can use. Right now you can use. But 7447 also, you may think whether you really need that 7447, or you can bypass it, do some tricky things over there. Okay, so please check. So these are the two things. While the first thing is mandatory, the second one I expect that those who are particularly looking for EX grade and so on, they can do. And why I am telling this, because generally we used to say that you do everything, and then we will evaluate. But as such, some people are complaining that right now we are in our hometown, there are many problems, like some family members getting ill and so. So we are leaving out the mandatory requirement. It may so happen that all the people are saying that all of them are we are not targeting an EX. Okay, so in that case, maybe you can relieve yourself that mandatory requirement is submitting the first one only, and second one is actually if you're looking, so that will compensate also if you can suppose if you miss one experiment, and then that extra marks, I think it will compensate those. So please attempt, because right now the problems are simple, so this might be having a tricky problem. And another thing also, that when you are solving something, so try not to use unnecessary thing. For example, we have seen that it initially appears that for resetting we require an AND gate. I think in the previous one we had drawn that B and D we are putting together to an AND gate. Later on you realize that we can eliminate that AND gate. So that means in terms of the system design, you can eliminate one full IC. Okay, so that will reduce the cost. So certainly I think we will look for those optimization, that the economy in terms of hardware is a concern. So when we are evaluating, we may evaluate in that way, that whether you have used unnecessary components or you tried to optimize that. Some components might be really unnecessary. Okay. So maybe today I think it has basically getting converted into a lecture class only. But anyway, I think because your lecture class has not progressed yet, yes, please.
In the 12-hour clock, how will you make sure that the second digit of the hour gets reset to 1 instead of 0?
No, that is what I said, that maybe you need to have some tricky solution. First of all, you may think of whether you really require 7447 for driving that. Okay. Think about 12 hours clock. Maybe I said that either 0 or 1, that digit will vary, that LSD if you call it. And any other alternative rather than 0.
Yeah, I'm actually talking about the next, like the LSB of the hour.
Okay, LSB of the hour, that has, if I tell that immediately it will become apparent. Think about the whole as a whole, that okay, uh, what will be the number, I mean, modulo, if I think in terms of modulus, what is the required modulus, or what is the required, what do I say, number of states, number of distinct states.
Okay, I got it.
I don't require 0, I require 12 states, 1 to 12.
Yes.
Okay, so take it in that spirit, whether
Yeah.
a modulo 12 counter or something. I think I have spelled out one of the probable solution.
Right.
And there are some tricky solution. I think you are not coming to the lab as such, and you need not have to do a debug. But still, I think that may happen even in simulator. I think maybe I will leave you before maybe 4:30. So I'm just so think. Okay, I think the paper is not visible. So, is the paper visible now? Achha, suppose I am having, am I audible? Hello?
Yes, sir.
Okay. So, I am having a 7-segment display over here and have 7 connections going from, by this time you remembered the chip numbers. What is the chip number? 74? 47. Okay. 7446 is also there. That is, I think, having a little less current driving capability. Not actually current driving capability. That is a different voltage also. Anyway, 7490 or 93. I'm writing 93. How many connections would go from 93 to 7447? Tell me.
4.
4. Okay. 4. Right. So while connecting these 4 connections, maybe you have mixed up the connections. That LSB of 7493 is not going to the so-called LSB of 7447. You have mixed it up. Either you have completely cross-connected that, say LSB goes to MSB and so on, or it might be a permutation of that. So you are not getting the proper sequence of 0, 1, 2, 3, but you are getting something else. So what is the easiest way to debug this? That exactly what has happened, which bit will go where. Suppose somehow you are not identifying the pins, that okay, which pin comes where. Actually, that may happen. I mean, there are some variants of the package where whatever you are getting in the data sheet, you may not get exactly the same pin configuration in the lab. But can you suggest some mechanism through which, just by observing that, you can find out what is the misconnection? So what is the easiest way or the fastest way of doing that?
Frequency.
I understand that, okay, you know the answer, but maybe if you elaborate a little bit, frequency of what?
Frequency of each bit. You can say bit change.
Yes. So I don't know whether your friends have got the answer. So if you see, this is the normal sequence of ABCD. LSB is changing like this, 0, 1, 0, 1. So in every clock cycle, LSB is toggling, right? 0, 1, 0, 1, 0, 1, 0, 1, 0, 1. Next bit is toggling at half the frequency, 0, 0, 1, 1, 0, 0, 1, 1, 0, 0, 1, 1. So if you write the outputs, that what is your observation, then you may find that actually the third bit that is giving you this type of 0, 1, 0, 1, 0, 1, whereas the second bit that is actually keeping throughout 0, maybe for first 4, then it is coming 1. So now you know that, okay, this is which bit, this is LSB. So then it gives you an easy way of exchanging that. Okay. But now my another second question, whose answer I think may not be that much simple. If I have mixed up this circuit, I mean the 7447 to 7-segment display connections, so then certainly I am once again not getting proper display. So then what will be the easiest way to find them out?
Current flow.
Yes.
can see the current flowing through the system. For every digit, you can.
No, I think you can see the display, right?
So we can just feed the binary inputs to the 7493 to the inputs of the 7447 and just check whether this digit is getting displayed.
No, but you have mixed up this say a segment, say small a, b, c, d, e, f. In place of a, suppose you have connected g. Okay, so
Right.
in that case, what would happen? Maybe I think it is slightly tricky, but just think of this one. Maybe, for example, you know that okay, when you are displaying one, then only two characters, I mean two LEDs are getting lit up. So if you have mixed up B and C with something else, so certainly in place of B and C, other two LEDs will glow. So where they are glowing, you find out one of them must be B, another must be C, and then looking into the other characters, probably you can find out. So think about that one. That might be an interesting problem to solve. But anyway, that is just as an additional thing. It's not part of the experiment, neither it is. I'm just saying that as a practicing engineer, sometimes you face this type of problem where for a given connection, you have to find out where is the fault or where is the misconnection. Anyway, so I think just right now, maybe what we have discussed for quite a lot. So you sort out what is the problem with the simulator. You can use even any other simulator that gives you this a simulation of these ICs properly, and TTL series ICs preferably. So maybe next week I think we will be having a full-fledged lab. So by that time I think maybe your friends, those who can also already install them, they can also help you. As I said, that helping the friends, they're really good as long as you are not sharing your results. So hopefully we'll be able to install it. And next, I think just one or two, I think, you are asking me about changing the time slot. So any of you are here by any chance? Because right now I think analog I was handling that slot changing, etc. But right now for digital I am not handling. Your theory teacher, Professor Gautam Shah, I think he is handling that slot change. Pushpalila, I think.
Yes, sir. That was me who asked for the
So could you finally solve this? I mean, you may talk
Yes,
to
sir.
So
Yes,
how
sir.
you have changed your elective or what?
Yes, sir. I changed my elective.
So what is the right now? What is the elective? You forgot the name of the elective?
No, sir. Actually, it is. It used to be science and rubber technology, science and technology, rubber and rubber-like materials, and I've changed it to.
To which one? You forgot the name of the elective that you have chosen. Anyway, so no, but I'm only my concern is whether it is more relevant towards your field of study. I do not know the other elective doesn't. I do not know whether you are doing it in consultation with your faculty advisor. But anyway, the problem is solved, right? I think your microphone is not coming up, or there is a problem. And another thing also, I must tell all the students that you please switch on your video from next one. Otherwise, I do not know really whether the student is sitting in front of the camera, I mean, in front of the laptop, or sometimes they are just logging in and going away. So please make it a point that you can have. And during examination, I think that will be mandatory. So please see. I think some laptops, some people earlier have said that they do not have any camera. So please arrange for a webcam or something else, or even you may connect through your phone if possible. So from next class onwards, I expect that I can see all of your face, even if it is online. I think that will. I also feel good. Right now, I am addressing some circles with the AS, AP, H, something written on within that. Okay. So,
sir.
Yes. You
For the
having a
clock
good
experiments,
clock, maybe. Acha, Amitaksha, do you have a camera right now?
sir, yeah, but I can't turn it on.
Okay.
I will turn it on next day.
Okay, sure. No issue.
For the clock experiments, do we need any external reset button or something like that? Like, should we keep that?
Just a moment, I missed your, I think Pushpalila is asking, no, I'm not being able to hear you. So you can write down in the chat box only. Amitaksha, I missed your while reading that chat box thing. I missed
Yeah.
your.
So, do we need any external reset switch or something like that in the clocks? Like, do we need to keep them?
In the clock or?
Like, in our clock that we are going to design.
Oh, okay. So